The Sporlan division of Parker Hannifin proudly sponsors the Advanced Refrigeration Podcast. There are a lot of questions surrounding the transition to A2L refrigerants and a lot of talking heads disseminating nebulous answers. But when your technician is face-to-face with the first A2L transition project, where do you turn for real-world answers about this specific job? Parker Sporlan's Virtual Engineer is an innovative online design tool to size and select the correct components for climate control and refrigeration applications. Get your A2L system flow and component selection answers in 3 simple steps. Enter your application details, size, and select products, then download your project files. It's that easy. Try it at absolutely no cost. Visit sporlan.com and navigate to the Resource Center. Parker Sporlan, leading the charge.
Be a lot easier, right? Instead of doing this whole thing.
Some of these stores, yeah.
Good afternoon, everybody. Welcome to Advanced Refrigeration Podcast. You're those Brett Wetzel and Kevin Compass. How you doing, buddy?
Oh, this has been one of those weeks. Just one of those god awful weeks.
You actually, like, you say that a lot, but like this week, you look tired. Like you have bags under your eyes. You look freaking exhausted.
Yeah, I've just been like running around, and it was in Atlanta yesterday, so I left at 5:30 in the morning from Chicago, went to Atlanta to go look at one store, and then flew back, and then dealt with a shit show on the way back, and had to pull over 3 times while I was driving to dial into a store, and and then ended up at said store this morning dealing with this absolute shit show.
I'm sorry.
Is what it is.
As you could probably still tell, I was in Jersey last week. That was fun. I actually had a great time. I got to visit some friends at the local 420 and did some training last week, which is leading into other stuff. So awesome. Although my calendar's booking up really quick. It's crazy. I don't know. Like I'm already booked up to almost July. It's actually literally insane. And I'm just working on some other stuff. Oh, no, I know. It is good. It's always that, I don't know. Like I don't know. You know how the Italians go. When they say they're a little concerned, they're actually a lot of concerned. But no cheesesteaks last week. So, yeah. So what are we doing?
We're gonna talk about dealing with short cycling.
Okay.
Oh, I didn't want to delete that.
Cheese and rice.
So I want to talk about short cycling, guys. Like short cycling on racks, short cycling on condensing units, and how to deal with this, because this comes up quite often. And some of the ways that guys deal with this is not the best, to be honest to you. Like there's a lot of misconception here on how to deal with short cycling and too many compressor cycles and stuff like that. So I just want to be first and foremost, lowering the suction never, ever makes this better.
What do you mean by that? Can you explain?
Lowering the suction set point of the rack will never, ever fix short cycling. It makes it worse. Because what you're doing when you lower the suction set point, especially if you have EPRs or even electronic EPRs, it's even worse. What you're doing is driving that suction pressure down lower than the EPRs. Then your EPRs start pinching down, or K start making temp, and ESR start pinching down. Then you have even less mass flow and load, and now you're going to cycle even more.
Those discharge temperatures aren't going to like it too. Stating about the mass flow, we just don't have enough flow going through the system. If the EPR is clamped down, that's going to stop the suction gas, and then in turn cause the suction to have extreme amounts of superheat because they're all clamping down, and then your suction pressure inherently lower, so you're increasing your pressure ratio, and you're just destroying that that compressor. What do they say? Compressors don't die, they're murdered.
Yeah, it's so an average cycle count should be no more than 10 cycles a day or an hour. So that's what they consider average. So it'd be 10 cycles an hour.
I'm going to disagree with you. If you look at your like the contactor manufacturers, they'll tell you they don't want it any more than 6 times an hour.
Okay, but
Like,
I'm saying the compressor manufacturers, like Bitzer says, no more than 10 a day or
Fair
10
enough.
an hour. So we're going on what they say technically.
Okay.
So no more than what they want an hour. So whatever the contactor manufacturers, just double the size of the contactor.
So solid state residential contactor, and they'll be fine.
Yeah. So that's where this issue comes in. You don't want to continuously keep cycling these compressors, because once you start doing that, then you're going to start wearing these things out, and they're going to get weaker and they're going to get worse, and then you're going to have all kinds of random issues. So you don't want to continuously cycle. The other thing is cycling kills your energy. So you don't want to have shit energy control on these racks. That's not what you want. You want nice, steady runtime on compressors, and you want everything to be steady and nice. And what's my train of thought here? You want everything to be steady, and you want everything to be smooth running. Because if you start having cycling and oscillations, that's when you start causing issues with the condenser. You start causing issues with the cases. So if the rack's oscillating, everything else is oscillating. When it starts oscillating, that's when you start burning through energy. If you keep everything steady and everything running, then you're not cycling compressors. You're not causing demand usage charges on the utilities. You're not beating up contactors. You're not beating up compressors. You're not wearing out valves. So short cycling is a huge issue. Now, the way I go about short cycling, if I see a rack that's just banging on and off, first thing I'm going to do is I'm going to go through the RS sheet. And I'm going to look at the RS sheet. What does the original design saturation call for? I see it all the time. You walk into the store, 5 pounds lower, 6 pounds lower. Okay, why? They add a case?
Because the one case wasn't pulling down, Kevin, so I had to lower the suction all the way down to Jesus.
Yeah, so was the one case not make a temp? So you're going to tank something it's going to cost thousands of dollars a month to run to fix one case? Let's fix the real problem here. Like, it's cheaper to fix the problem. Now,
right?
Yeah.
Okay.
So I will look at the RS sheet, and I will look at and see what the original suction pressure design was supposed to be, what the original condenser pressure design was supposed to be. Get it as close to what it was supposed to be from the beginning. Look at your cases. Look and see what your evap temps in your cases. Like, I was looking at one the other day. Rack was a plus 18. The coldest case was a plus 24. So yeah, it was short cycling. It's 6 degrees colder on the rack header than the coldest case.
Clamping down the EPRs, and regardless if they're electronic or they're mechanical, they're still going to have to clamp down to maintain that EPR pressure. That also means that you're injecting a little bit of gas directly in the suction as well. Because remember, for the externally piloted EPRs, they use that discharge gas to help close, and they release some of that pressure down that little line.
And then, like an A8, the more pressure drop you get across it, the larger the valve becomes. So the poorer the regulation you're going to get.
100%.
So if you get hunting in cases, you may have a huge pressure drop across the header. A 2-pound pressure drop is substantial on an A8. A 6 to 8 pound pressure drop, you could almost double the size of the valve. So you got to be real careful when you're doing stuff like that, because you may not get valves that shut properly with that on an A8, and you may be skipping random defrosts. So that's another thing to look at. Now, as I'm looking at the RS sheet, I'm looking to see how well this thing's maintaining suction pressure. Is it bouncing 30 pounds like the one I was working on today? It was swinging 35 pounds back and forth.
What was it, because the EPRs were slammed down to nothing?
It was standard A8s, and everything. It was running like a 9 degree SST set point, and the coldest thing on the rack was a plus 18.
Damn.
So it was just slamming down. Like number one compressor had 800 cycles a day.
What the fuck?
Yeah, so I'm going through it, and this ended up being a bunch of stuff. So I'm looking at a couple things. First off, I'm looking at what is the suction saturation, what is it designed to be, and what is it? Is it floating? Is it set up to float? Did some jackass put a negative float in? I don't even know why that's a thing.
Can I just input something right before we get into all that stuff that you said?
Yep.
One of the things that I think we should do is check to make sure that the compressor is actually functioning the way it should. Because I've seen during a PM, sometimes some customers request you to take a look at the dip switches, and let's just say someone thinks they know better than what the paper says. They might end up putting that thing where it's reversed, right? Or they flick a dip switch because they were trying to turn something on, they left it on for a little bit, and then they walked away and forgot. So then that compressor thinks that on is off and off is on, so it overshoots like crazy. I had a friend of mine today, they were looking at the same similar situation. And it was weird because the low pressure switch and high pressure switch shook themselves to death and were open. The compressor wasn't on, but somehow, some way, because usually if a controller sees that you have a proof failure, it'll usually lock out that controller. I don't know if that's 100% with this RDM that they were dealing with, but apparently the proof hasn't been working either. So if the suction pressure starts going up high, it'll try to kick on that one compressor. And then when it doesn't, it'll kick on the next one. So then when the suction pressure starts to barrel down, it'll shut off the compressor. Maybe it'll try to shut off the compressor that it started first, and then nothing's happening because it thinks that it's there. And now all of a sudden you're overshooting on that. So suction pressure, just make sure that the pressure transducer is straight, because people are silly and they'll put offsets and stuff because maybe their gauges are off by 5 or 10 pounds, which we've seen.
Suction pressure transducers are not off by 1 pound. Generally. Your mechanical gauge versus that transducer, I trust the transducer any day.
And don't use a compound gauge where the increments are 5 or 10. Don't use a set of 4 10A gauges on that shit. But use an actual something that if you are going to use analog gauges, which most of you probably are not, use something with an incremental actual, like one PSI incremental. So you're not like, oh yeah, it's, you know.
I see it all the time. I go to a store and it's 5 pounds here, 5 pounds here, 5 pounds here. And that's odd that all the transducers are all off by 5 pounds. That's really odd. And I zero them all out and I'm like, okay, throw my digital on there. And I'm like, that's really odd. None of them are off.
Maybe it was because my analogs were off by 5 pounds. I don't know what's wrong with this rack. Every pressure transducer is off by 5 fucking pounds.
But yeah, come on. Like, you use your brain. Like, it's not off by 5 pounds. It's your tool. So
maybe it's not.
So that's one thing. Then the next thing I start looking at is compressors. Okay, are the unloaders functioning properly? We just had this at a store where Danfoss conversion was done, and Danfoss is a little different. And when it calls for an unloader to be on, they're calling for another stage of capacity. They're not calling for it to be off, meaning like a less of a stage of capacity. They're calling for more capacity.
Same thing with CPC. When that says on, the unloader should be unloaded.
Yeah. Now, a Copeland and Carlisle are backwards. A Copeland is energized, unloaded. It unloads. A Carlisle is energized, loaded.
But it also depends on the compressor. Verify. Verify, because like a 5H, I think, is different, where it has hydraulic unloaders, and I think it energizes.
The other way.
Yes.
Yeah, and then Bitzer is Copeland. It's the same way. Energized is unloaded. So pay attention to that, because we had it where it was wired. It was wired normally open in Danfoss. That was wrong. It should have been normally closed. So when it called for it to be on, it was on and energized, and when it was off, it was actually unloaded.
Gotcha.
So that's an issue, and just make sure that those are set up, or your dip switches are set up in CPC for the unloaders. Make sure that compressor actually drops amperage when it unloads and loads, because I just had one the other day where the unloader was sticking and it wouldn't change amperage.
Yeah, and the other thing, especially if the compressor has just been changed.
Is the unloader put back on?
Or, no, I was going to say the shipping gasket's in there. Where they leave the shipping gasket in there and it doesn't do shit. It sounds a little bit different, but unless you actually visibly check so don't say, oh, it sounds different. That doesn't mean shit.
Sounds more compressory.
It sounds more compressory. Check the amperage. Don't worry about how compressory it sounds.
You can hear a Copeland load. It usually makes that like clickety noise, that weird noise.
I know what you're talking about.
It makes that weird noise where it
sounds
breaking.
Compressory.
It sounds like it's like breaking for a second, then it just gets quieter. So it's like a weird crack. But yeah, it's clack. But yeah, make sure the unloaders work and make sure that the compressor, if it came with an unloader, I don't know how many racks I've looked at where the service department's gone through and changed the compressor and they didn't order a head with an unloader or take the head off the old compressor. And, it didn't have one. Service manager says, just put the compressor in. Don't worry about it. We didn't order it. It didn't have the unloading head on there. Now you lost a whole stage of capacity.
Yeah, there was a customer out there, for some reason, they deemed that they didn't need unloaders. And when they started to do remodels, they didn't have the unloader on there, which was a bad thing because it was one of those problems where we ended up having no EPRs on the thing that we switched out to case controllers. And so because they switched out to case controllers, because the lowest SST on the medium temp typically is the meat box, which is at plus 18. But now when you do a remodel, you went from something that had like 8 or 10 degree TD to everything that has like a 4 degree TD. So now you don't have to maintain 18 or 20 on those cases. Now you have to essentially maintain 28. So what ends up happening is you're shutting off and turning on load, turning off and turning it back off. And so you have this massive load situation because the expansion valves on case controllers typically will then, once they maintain case temperature, they'll just stop modulating or go to a minimum position, which ruins out of any kind of control.
Biggest lie that manufacturers ever sold was case controllers don't need EPRs.
I 100% agree with you. It caused if you had more of a steady suction. Why do you think we go through so many more compressors nowadays than what we ever did? Everything was like the straight, solid, saturated suction. Back in my day, it was all like a lot of them had the same TD. So it was running a lot of the same pressure. So the load was very constant. Like the case over in Europe, from my understanding, from what I was told, that they run a 10 degree TD even on their cases. What's that one manufacturer that they were putting a bunch in the liquid pump overfeed stuff? Cases that you really like. Not Amitech. Not is it?
Carter?
No. They were doing it at Wally's store. The coffin cases with the plastic over the top.
Arneg?
Yeah, that one. Yeah, those have a high TD on those. And apparently all European cases are like that. Plus, I also
like 10, 15 degrees. So like they're
right?
like super inefficient, which is they're like way behind us. And they got us at beating racks, but cases, we smoke them. But okay, so back to making sure the unloaders work. Make sure all the unloaders work. Make sure the compressors are all correct. I've seen racks where, okay, why is there a 10 horse here when it's supposed to be a 20? Or why is this all messed up? And then in the controllers. Now, I'm a big proponent of this, and I've seen it fix a lot of stuff. So stuff where, like in E2 or E3 or Danfoss, where you have compressors that are all the same capacity. So the 10 horse and the 10 horse. I program them all differently. I'll make one at 10, one at 11, one at 12, one at 13. I make them all differently because the controllers don't seem to react in the algorithms. Like especially the E2, it tries to equalize runtime if you have multiple compressors that are the same horsepower.
Yeah, and then it has a bunch of unnecessary cycling because of it.
Yes. So always make them different sizes, even if it's one number off. Now, the bigger the number, the better. I always go with BTUs or MBTUs or CFM or CFH. I usually go by one of those numbers. I don't use horsepower. I don't use
something big. Something big. The algorithm likes bigger numbers.
Yeah, horsepower sucks for that. bigger numbers, anything it's in like if it's in the 100,000s, that's perfect. 100,000 BTUs, whatever. That is a perfect number for that. So using that and making sure that your staging is changing. Fixed steps, no go for me. Like you're not going to beat the controller.
I don't know why that's a thing. Is there a reason why?
Because back in the day, like the RMCC used to suck ass for staging at times on certain things. I could see like it in 1990, like same thing with Comtrol, like it was just awful back in the day.
Comtrol wasn't bad.
Comtrol was awful. Like people to say that Comtrol was great, Comtrol was awful. Those boards that are vertical that you got to pull out and short every time you got to pull it out, those things are awful.
Whatever. I like it.
The CPC was the original GOAT.
Fair enough.
But making sure that the capacity is right in the controller, okay? And making sure that you have different numbers. Now, I'm a big proponent of float and suction. Floating the suction oftentimes will fix a rack like this. So if you're able to float the suction, get it up 5-6 pounds, and you could do it safely and monitor the case temps. You're also saving energy. And as you float that suction up, you may be able to do more work with a smaller compressor. And that smaller compressor may sit in that window and cut the cycling out with floating the suction.
So if anyone doesn't know what floating suction is, it's being able to raise the suction set point based off of usually the lowest SST case. I've seen people screw this up and they're like, oh, the lowest case is the meat wall, right? Set at 28. But then they didn't realize that they had that meat wall only had to be at a 24 degree saturated, where they had something else on there that had to be at 32 degrees, that had a 10 degree TD, which means I needed to have it like 20 or 22. And then essentially it starts floating off the wrong thing. And that one case doesn't actually work or maintain properly.
Do not use a walk-in or a closed case unless you absolutely have to.
Correct. But what we're essentially trying to do is we're treating the whole suction header as an EPR. The idea is that whatever the suction pressure is at the header translates over to that case. So if you were to have an EPR, you have to make sure that thing is not adjusted, where it's not doing anything. If it's a mechanical EPR, if there is a electronic EPR, if you do something to make it the lead case, it will actually float off that one.
I never do that, just for the fact that you don't want it to become an issue. I usually set it colder and make a fake circuit. So what I do with electronic EPRs is I make a fake circuit, and I call it float, and I assign the inputs from the other circuit. I will make the set point like a degree or two colder in the actual circuit. So that way, if there's an issue with the float or something happens and it overshoots, you still have the electronic EPR as a backup, so you don't overshoot the case and get a low temp alarm, and you don't have to worry about that nonsense, but it'll also still float up.
Gotcha. I just wanted them to understand like what the hell float is.
Because an electronic EPR, it will pin the ESR at 100%, even if it's below set point, if it's the float case.
Agreed with that.
Yeah. So floating the suction usually helps big time, because what it's going to do is it's going to keep increasing that suction pressure. The closer you get to those EPR settings, the more open they are. The more open the EPR settings are, the more steady your mass flow is coming back to the rack. And the more steady the mass flow is, the less changes in suction pressure you're going to have. Now, you just got to watch your floating and make sure you don't cause case issues. You're going to find some cases that don't make temp when you start adding in floats. Address them as you go. Don't stop the float. Go figure out the issue with the case. Especially if the coldest case is making temp, you get other issues.
Yeah, most of the time you'll find that you had an underlying issue, and it was masked by not being able to float the suction, where they had to pull that suction all the time in order for that case to pull out in temperature. So now that you're actually floating properly, you're going to find issues. And I've seen this time and time again, where like someone will implement float, and then we'll say, this thing doesn't work, I'm going to just take off the float. Okay, the contractor just paid a crap ton of money to make that thing energy efficient, and you're just going to be like, nope, we're not going to use it. Look at the case, find out what the hell's wrong. Typically, it's either icing up for some reason that was underlined or some kind of superheat issue. Because theory is
some fucked up piping issue.
Yeah, we talked about this before. You got the airflow, SST, and superheat. If you have all three of those things, that case should be able to pull down temperature, no problem.
So the other thing is that there's this whole like misnomer that you need the rack to run 2 degrees colder than the coldest SST. That's BS. I generally will set the rack at whatever the coldest is. And if we have a pressure drop, then we deal with it then. Most newer stuff and most older stuff, you shouldn't have that massive of a pressure drop.
I think why they do that is because if you look at it's just what they do on the refrigeration schedule, right? So whenever the engineers are like, okay, if this is running at this, we're going to say that it's 200 feet of pipe and we're going to get this much pressure drop.
Yeah.
Because you're not running full load all the time.
Correct. You're not running full load all the time. You may get a slightly slower pull down of your defrost. Who cares? It's better for it anyway.
Today's episode is sponsored by the RefraShield RDP Series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP Series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales@westermeyerin.com. That's WESTERMEYERIN.com.
Sometimes, and I hate saying this, it's non-avoidable because you might have cases that are from 1970-something that have more holes in it than someone that I know is alibi, but it's because you literally it's letting in so much moisture that they're having to do that. For anything newer, you should be able to achieve that temperature and by not having to defrost it 300 times a day.
Yeah, like I was in a store the other day that had 3-year-old glass doors with 4 defrosts a day in them.
How many of the honeycombs were like leaking air where the cases go together?
None of them.
Oh, okay.
3 years old. There's nothing wrong with them.
Well, all right, fair
so
enough.
It's just the contractor that did it decided that glass doors need 3 defrosts a day, not 1 defrost a day. The rack was constantly in defrost. It was constantly having load issues. So as soon as we cleaned up a defrost schedule and paired up loads that are smaller together and loads that are bigger together with nothing, so that way when a big load comes out of defrost, you aren't tanking the rack. And the other thing is, I'm a big proponent if you do have a big load coming out of defrost, you schedule another load to go in right around the same time. So when that load comes out of defrost, the other load goes in and you don't get this compressor cycling in between. You don't stage up the rack to pull the suction down, and at the same time, you're shutting off another load and it's just like crashes and falls on its face.
Yeah, you get it. Sorry. I would say you get it as close as possible because you are going to have some deviation depending if maybe it's not humid out, maybe you're not adhering a lot of moisture because the humidity in the store is actually suitable. So that's going to be a deciding factor. Also with the defrost schedule, making sure the termination is set right. We don't need 70-degree defrost term on a frozen food. That just wastes so much energy. Dude, ice melts at what, 32.1? So if we get it up to 48 to 55 degrees, we should be straight.
Same thing with multi-deck cases. You don't need to run up to 50 degrees on multi-deck cases. That just adds a ton of load to the rack, and this instantly causes short cycling because it's going to pull that case down. It's going to get a lot of load real quick, and it's going to short cycle. It's going to come off and come on. So I'm a big proponent of using the discharge air to at least cycle the multi-decks on term. And then as you're looking at stuff, condenser control. Okay, there's no reason to be running a 90-degree condenser control, 80-degree condenser control. Everything we do should be able to maintain on 70 on a rack. If you can't maintain a 70-degree condensing temperature with the floating, something's not right. Like Just because it's Florida doesn't mean floating head doesn't work. Something's going on. Like it works up north. It works in Texas. It works all over the country. It works all over the world. Floating head pressure works. And as you're floating that head pressure, especially in the wintertime, you may be able to reduce that compression ratio, and you may be able to use a smaller compressor and make it more efficient to cover the gaps in the load.
Yeah.
And if you get to a point where none of this is working, it may be time to look at like compressor sizing and looking at the rack. Has it been remodeled? Glass doors been added? Is it time to talk to the customer about adding a VFD to a compressor or doing a digital? All these things pay for themselves. So as you're trying to convince a customer to do this on a rack that's cycling 250 times a day, it's a pretty easy upsell when you look at the maintenance side of it and all the costs with it cycling like that. You could pretty easily sell a $5,000-$6,000 VFD or a head kit. I probably did 30 or 40 head kits a couple of years ago. I love doing those Copeland digital head kits. They work out great, and they flatline racks.
Wait, the digital you said?
Yeah, so like the retrofit kits for the...
Is that the one with the big ass block on the back? Like on the back of the suction?
No, the retrofit kits for the Copelands, for the digitals.
Okay, never mind.
So you change out the head and add an IDCM, and you obviously need an analog output to give it a 1 to 5 volt signal.
Mm-hmm.
But right there, that instantly fixes most of the rack cycling. And not when I'm looking at stuff like this, I generally don't choose the smallest compressor. I choose the compressor that's going to meet the capacity most of the time. So you want that compressor running. I generally want to choose like the middle of the road compressor. I'm not going to usually choose number one. I want to be able to run the smallest compressor and that compressor at the same time. And I'm never going to choose one that already has an unloader on it.
So I have a question. So it would make sense. So obviously we don't really want to try to unload anything more than like 25%, right? We already talked about that once upon a time. So my question is to you, because I'm thinking about this, because as we all know, a compressor increases capacity as your saturated condensing temperature goes down. So if you're in a place like Texas where it's running 120 degrees saturated condensing temperature in the summertime, if not hotter, and you go down to floating head, you will actually increase that compressor by 25%. If you do that, would you middle of the road a compressor that's able to do at least that capacity? See, it's messed up because it kind of screws it up a little bit, because for all these newer stores without EPRs, with case controllers, who's to say you can figure out how many cases are essentially going to be shut down? I was at a store when I didn't have soft hands, and it had
half or more.
Yeah, like half the expansion valves. I think it was like literally 3/4 of the medium temp expansion valves were like, nope, I'm not going to run.
Yeah. When I'm doing these digitals, even though I would do a digital on a rack, that wouldn't just say I was just doing one digital. I may add head kits, like unloading heads to another compressor, non-digitally, so it's way cheaper, but I may add an unloader kit to 1 or 2 more compressors to give you a little bit more staging gaps. So that way you can cover it. I generally never choose the smallest compressor, and I'm definitely not going to choose the biggest compressor. So I usually choose the one that's going to be the middle of the road and give me the best control overall. A VFD is awesome. I try to avoid using 4Ds, because a 3D you get way more turn down.
Unless you have a digital.
What's what I'm saying? A digital 3D, you get way more of a turn down than you would a 4D. A 4D can only go to 50%.
Okay, agreed. Okay.
So, yeah. So you can only go to 50%.
Unbelievable.
I generally choose the 3Ds. You get way more control out of a 3D. It's just way better control. So I like 4Ds for their block suction unloading. A 3D, I'm not a big fan of the module loads. They're dependent on head pressure of how much you're going to get. So if I have a module load, I'm going to keep it and then choose a different compressor to do the unloader on. Because a module load, as the head pressure decreases, your unloading decreases.
Does it really?
Yes. So it is dependent on head pressure. How much you want.
Where's that labeled?
It's in the module load AE bulletin. It actually decreases quite a bit. So as the head pressure decreases, your unloading capacity decreases. So that's why it's hard to judge a module load. You may be able to get 30% unloading in the summer. You may only get 60 in the winter. So that's where it becomes an issue.
I've never heard that. That's interesting. I didn't know that.
Bidsters, I will say, they will let you unload the whole thing, both heads, which I'm a big fan of that. When they do the 4 cylinders or a 6 cylinder and you can unload all 3 banks, that's pretty sweet. Except the old unloading software was so slow.
Which one are you speaking of, sir? Are you talking about
the original, like with the Siemens board?
The card with the card in there?
Yeah,
I got one in my garage.
The thing was awful slow. You could have done it with a RO board and been fine.
Yeah, one of the things we talked about when I was out at class last week was being able to, because you said you like the VFD. One of the things we can do is increase and decrease the amount of, to get a little bit more time with it, is be able to slow down or speed up increase or decrease time. Like how fast it's able to slam on the brakes or how fast it can turn up the gas to get that thing loaded back up.
The VFD is always going to give you better control. It's going to give you smoother control. PWM modulation is great for stopping short cycling and smoothing out a rack. It just does. But if you don't have EPRs, PWM sucks for that. You want a VFD is a much better choice for like case control operation.
Okay. PWM is pulse width modulation. What we do with our electronic expansion valves, what we do with our digital unloaders, like a digital unloader on a scroll, I think the cycle time is 20 seconds. So if it's 50% unload or 50% unloaded, it'll be 50 seconds on, or I'm sorry, 10 seconds off, 10 seconds on. So that's what that is. You're pulsing at a rate. Same thing we do with the older Advancer oil systems and such.
Yeah, so it's going to use a solid state relay inside the controller to pulse it on and off a bunch of times. A normal relay would wear out way faster. So that's one thing. Adding VFDs, like even like corporate customers, like I have talked so many people into adding digital heads or VFDs. The cost is not as bad as everybody thinks. And the payback is fast.
Too bad we can't convince them just to put EPRs in a freaking store.
Yeah, they're starting to. It's starting to become more and more prevalent, especially with the CO2 stuff. People are realizing that like the case controls is ass. Doesn't matter how much tuning you do, you can't control 3 variables at once. It just
any little fluctuation in that suction pressure, the expansion valve gets confused on what the hell to do. We've heard stories about a project that some other customers doing. They're having a hard time maintaining glycol temperatures and CO2 temperatures because any other primary, secondary type system, there's usually either a digital unloader or some kind of VFD compressor. They don't have a 40-year-old Comtrol unloading technology, loading and unloading that stuff.
Yeah,
can't maintain great superheat.
You're never going to get it right like that. And then the next thing is making sure that the subcoolers are working and all that stuff set up. Make sure that you aren't running compressors harder than you need to be and you're short cycling because subcoolers aren't working on the rack and you're needing to use more compressor than you normally would, that it would cover that gap. So that's another thing to keep into account, making sure that is working properly. And then your cases, EPRs are balanced. I find if you have EPR cycling on temperature, no good. Never cycle on temp.
I think part of the reason why they did that was because pressure transducers, when electronic EPRs were being implemented, let's just say you have 30 different circuits, right? You have old school Tyler parallel rack, you got 30 circuits. That would require then 30 pressure transducers. And this is before they had case controllers, but they really didn't really have really good control. Now we have these where if you can control your pressure, like we keep harping on it, you keep a constant pressure, the expansion valves aren't really changing how much they're opening and closing nearly as much.
Yeah, like going through and setting all your EPRs on a rack, making sure everything's balanced, because Every time I go to a rack, it's got set up for temperature and defrost. It runs like shit. It's short cycling, and what happens is one or two circuits shut off, the suction tanks, then it starts tanking more, and it starts this like whirlwind downfall of just short cycling because one or two cases shut off on temperature and it lost a load. Then it gets the load back, and then boom, it's just this constant fighting. So you should not be using temperature and defrost. If a customer demands it, yeah, but like you need to really go through and fine tune all your EPRs. Get all your EPRs set. Make sure you don't have cases that are swinging temps all over the place. You want nice, steady temps. And when you go through and set all those EPRs, that makes a huge difference on the rack operation.
People usually lower the EPR for a multitude of reasons. Typically, it's because it wasn't working right. Typically, is what you get. So I lowered the suction pressure down, and we've discussed this before, but I'm going to bring up one more little thing here. So we talked about this numerous times, but now I made a chart because I'm lame and a lonely man. I have nothing else better to do. So I took this. This comes from one of the evaporators that's out there where it labels like the different TDs. So typically this number right here is the amount of BTUs that's in that case has, or that evaporator has. So in this example, we have a WK 1300. Okay, that's at a 10 degree TD. Now look what happens when we go to a 15 degree TD. WK 130 now has 1,000 or 19,500 BTUs. And then if we want to really send it to the moon, where we have a 20 degree TD, now all of a sudden that coil now is 22,100. Now lowering that suction, yes, will make the coil bigger. Oh, the expansion valve should just open up more. The expansion valves have a limit. Typically, you're not doubling sizing the expansion valve that's in there. So a lot of times what will happen is you'll end up starving out. So that's another reason why if your EPR is set too low, essentially what it'll cause is your expansion valve to have high superheat because now the coil is way too big, and then cause feeding issues as well as high superheat and not maintaining temp.
You see this all the time in like open air POS boxes. All the time.
I agree.
Like it's a huge issue that guys will open EPR and then all of a sudden now the expansion valve is too small. And then now they have superheat issues when they're really chasing a saturation temp issue that is masking itself as a superheat issue. So making sure EPRs are set, like going through, taking the time to go through and set every EPR at case design, and then just watch it. Figure out where your issues are. The cases that warm up. You got plug strainers, you got plug dryers, they start showing up. That's part of your cycling problem. You don't have enough mass flow going through the cases, and people have been opening up EPRs to hide it. Next, you got to go clean 20, 30 strainers, and that was your problem all along, but people were hiding it by lowering the suction and lowering it, and it's just making the problem worse and worse until it starts short cycling enough where it's a problem in the wintertime when you're not feeding it up through the valves.
You're just expecting way too much. No, he's right, though. People will do stuff to hide stuff, and that's why I don't understand when energy optimization was really big 10 years ago or even 15 years ago. They have one contractor do the programming in order to do that, and then they rely on the primary contract that's on site to essentially fix any issues that are behind. And that's what I was stating. A lot of times, maybe they don't want to change out 40 filter dryers in your cases. You know what I mean? And so it's a perpetual thing where it keeps having issues. We're just going to keep lowering the EPR. We'll get it down temperature. So though people put Band-Aids on stuff so they don't have to address it now.
Yeah, you're going to address it now or you're going to address it later. And I'll tell you what, I'd rather address it now than 2:00 in the morning if you're running calls for plug dryers. Dryers belong at the rack, not at the cases.
Yeah,
Nothing makes me more mad than seeing dryers in cases.
I don't understand that. If you have screens in the expansion valves, BQ valves, why is it even a thing? The other thing, why don't we have expansion valves? And I'm not talking about the pulse width. I'm talking about the bipolar. There's only one or two that actually, Sporlan makes one. They actually make two versions, but I don't even know why that's a thing. It should be one version that has a strainer, because I'd rather have gunk in the strainer than gunk in the actual expansion valve, because I'm lazy. You can't take off the head off those.
It takes 10 minutes to close the hand valve, let it pump down, and clean a screen, swap a screen in the fly, and you're done. You're on your way home. I'd much rather get that at 2:30 in the afternoon on a Friday than, oh, I got a 5-degree TD across the dryer, or I got I'm frosted on one side of a dryer. I got to go change the rest of them out in the lineup, because don't be that guy that changes the one dryer and there's 2 other dryers in the circuit, because those are plugged too.
Yeah.
I mean, it's that is a huge thing with short cycling, and dryers plug up over time. Like I don't want dryers in cases unless the customer specs it. I make everybody cut them out, because eventually it's going to plug up over time, and then it's going to make a million service calls, and it's going to make the rack run like shit.
Agree.
That's why they put catch-all cores at the rack.
Yeah, the only thing that sucks about sometimes, if you have a hot gas defrost, sometimes because you're bypassing the hot gas directly in the line, then you could put all that crap that could be coming from the discharge line. You know what I mean?
Yeah, I'm a big proponent of that spoiling sock that goes on the dryer shell to clean it up. That thing works real good, especially during retrofits. But yeah, taking the time, guys, and just making sure this rack is set up like how it was designed and trying to make it more efficient generally will fix your short cycling. Start with the suction, move on to your defrost, and then move on to your EPRs, and then start looking at your cases. And then that'll help fix all these short cycling issues and get you close. And if it doesn't, and you start looking at it, you have that oversized of a rack, then your only other options are some kind of unloading or some kind of digital compressor or variable speed. And you know what? Like, I enjoy doing those jobs. I think those are fun jobs. Taking a rack that was running 300 cycles a day, cut it down to 10 or 15 cycles a day. And we've taken them that low with digitals or VFDs. It really helps, and it makes the store that much better. And it's just less service issues later on. You fix this now, and you're not changing out clamps and broken lines and worn out contactors and burned up oil. You're just dealing with it now instead of dealing with the 3 million consequences it's going to make later.
100%. I think we hit it.
Yep.
You good?
Yep. Thanks for listening, guys.
All right. We'll see you next time. Bye.